All right, let's try another one here. Let's imagine that we've got a system, g of s is equal to 10 times s plus 10, 0 at 10, and then an s squared plus 3s. All right, so the first thing we want to do is factor out two free s's, and in this case it's pretty simple. S plus 10, s, factor an s out, and s plus 3. So what we end up with is a pole is 0 and a free integrator. All right, so this is going to tell us a little bit about what's going on with the system. But first thing we want to do in plotting the Bode is find the DC gain. All right, and the DC gain, remember, we're going to ignore any free s's, and so in this case, taking the remainder s's to 0, what we end up with is 10 times 10 divided by 3, which gets us 100 over 3, which ends up being 33.3 as our raw value for our DC gain. And then if we represent our DC gain in dB, we end up with 20 times the log of 33.3, and that ends up being 30.455 dB. Okay, so that's going to be our first point that we're going to identify on here. So we start labeling this 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4. And I'm going to start here at 0, 20, 40. These are dB. Minus 20, minus 40. And so coming up here and finding 30, we end up with a point here at omega equal 1 at the magnitude, our dB is 30. Now, okay, so we've got a point, and so we've got a starting point. We need an initial slope of the line because we're going to then make changes in the slope of the line based on where we find our poles and zeros. And so, but we need an initial slope. And remember again, our rules tell us that our slope, our initial slope, is determined by the free s's, whether we have an s in the numerator or s in the denominator. Actually, in this case, we have an s in the denominator, and so we're going to start with an initial slope of minus 20 dB per decade. Okay, so we're going to come off of this point and run a slope through at minus 20 dB per decade. So that's going to take us right through here. And so we start off with a slope like this. It's not going to need to go all the way, but that would be our slope of our initial. Now, one of the things that when you're looking at a Bode, if you see this initial slope, that should key you off to tell you, oh, I've got a free integrator. That means I've got a type 1. That means I've got zero steady state error for a step input for this kind of system. Okay, so this we see the similar kinds of information just in a different, presented in a different form. So that initial slope tells you something about the type of the system. Okay, so coming in here now, we're going to look at the next largest pole or zero. In this case, it's at 3. And so we've got a pole at 3, so we're going to go down even more at 3. So we look over here, and let's see, that would be 2, 3, so about in there would be our 3. And we're going to go down 40 dB per decade. So I'm going to go over 1 decade, which would take me down there, and then down 40, 2 blocks. And I have a line, very squiggly line running through there like that. Okay. Now, I'm going to follow that line along till I hit 10. Okay, and which is the next largest pole or zero. In this case, is a 0. And so I'm going to hit 10. Actually, I hit that right up in here. And so at 10, I'm going to add 20 dB per decade to my slope, and I'm going to go back to 20 on here. And so I go over 20 down here, so I should end up somewhere around in here. So my slope looks something like this, if I had a steadier hand. Okay, and so that would be my slope of my Bode. And if we try to smooth this out a little bit, it's going to kind of wave through here. And we end up something looking like that for our magnitude of our Bode plot. All right. So now, thinking about the phase, then we end up, of course, the phase is a function of the slope of the magnitude. So it's going to be the slope times 90 degrees divided by 20 dB per decade. dB per decade. There we go. Okay. In the first case, we've got minus 20 dB per decade times 90 divided by 20, and so we're going to end up at minus 90. The second section there is going to be minus 40 times 90 over 20, and so it's actually going to be at minus 180. And then the third section is back to minus 20 again. And so looking at this, we're going to end up, let's say 0, 90, minus 90, minus 180. We're going to end up at starting off at minus 90. And so we're going to run minus 90 over here to 3. It's going to be right there. And then we're going to shift to minus 180 to 10. And then we're going to go back to minus 90 again. So we're going to get a little dip in this. Now, again, this doesn't happen instantaneously as we've shown it here. It happens over a couple decades. So we're going to come back here, and then we're going to jump forward here, and we're going to do a line like this. And then we're going to jump back a decade to here, and here. And we're going to jump forward a decade here, and we're going to draw a line like this. And so our true Bode would look something more like this phase plot for that. Okay, now again, remember, we're just trying to not only visualize the Bode, but also getting familiar with our tools and what our tools do. Our gain in here will move the plot up and down, and each pole or zero, each pole is going to drive it down, and then each zero is going to drive it up. So we can reshape this Bode with our tools, our poles and zeros.